Data flow diagrams are useful for illustrating a transaction and transformation-based system and for presenting the boundaries of that system. Now let's look at what you'll learn. We'll be discussing what a data flow diagram is, the data flow diagram notations, the main components of a data flow diagram, the levels and categories of a data flow diagram. Then we'll discuss data flow diagrams, rules and best practices. We'll take a look at some examples of data flow diagrams, and then we'll look at the different types of data flow diagrams. What is a data flow diagram? A data flow diagram is a visual model that represents the flow of data through a process or system. Data flow diagrams are used to show where data comes from and goes. It shows which activities transform data. It shows which outputs are stored in the system. And it also shows which outputs are utilized by other activities or entities. Let's look at some of the common notations of a data flow diagram. First, we have the Jordan DeMarco and the Jordan code. As you can see, both represent the entities as rectangles, the processes as ovals or sometimes circles. The data flows are lines with arrowheads. However, the data stores in these notations are different. Jordan and DeMarco represents the data store as two parallel horizontal lines, while Jordan code represents the data store as a rectangle with the right side open. The SSADM notation, which stands for Structured System Analysis and Design Method, usually swaps how the shapes are used. Here, the entity has a circular shape, while the process is a square. The data store here is also a rectangle with the right side open, and the data flows are lines with arrows. Now let's look at Gann and Sarson. Here, the entities are rectangles. The processes are represented through rounded rectangles. The data stores are also represented as rectangles with the right side open, and the data flows are lines with arrowheads. In the process node and data store, you'll notice these reference numbers. We'll talk more about those later. Through the remainder of the lesson, I'll be using the Gann and Sarson notation since it does have this additional component. So the main components of a data flow diagram includes external entities, processes, data stores, and data flows. Now let's take a closer look at each of these components. External entities are outside objects that interact with the system. These objects could be a person, organization, or another system. Entities can also be classified into the following subsets. A source is an entity that provides an input to a process. We'll see this when the entity inputs or sends data to a process in order to change it. Data flows point away from the source. A sink is an entity that is a destination for the process outputs. Data flow arrows point toward the sink. Also, an external entity can be both a source and a sink, and this can be identified when the data is flowing to and from that entity. When adding descriptions, the external entities should always be labeled as a noun, for example, customer. Now let's look at processes. A process is an activity, which can be manual or automated, that transforms incoming data into outputs. All outputs must have at least one data input and one data output. There are two key considerations for labeling processes. A process description must be in an active verb-noun format, and a reference number is placed above the description to indicate the level of the diagram as well as the process placed within the function. For example, the process here is labeled as order item, where order is the active verb and the item is the noun. Also, this process has a reference number of 1.0, which indicates that this is the first process we're examining in the system, and also that we're at the level 0 data flow diagram. We'll discuss more about the reference number notations in a moment. Data stores model a repository for a collection of data at rest. Each data store must have inputs and output data flows. Data store labels must be a noun phrase, such as order details. The gain insertion notation also includes a unique identifier for the data store to distinguish the various data stores from one another, since there can be multiple within the same diagram. Now let's look at data flows. A data flow is the representation of data or information moving between external entities, processes, and data stores. Data flows will either be an input, an output, or both. Data flows are always labeled as nouns. For example, sales order. There are various levels of the data flow diagram, which are determined based on the level of detail needed to represent the data flow. The levels are facilitated through system decomposition. Now let's take a look at each one. The first level is the context diagram. The context diagram is the highest level diagram that represents the general function or boundaries of the entire system. It only contains one process node, which is process 0. This could be interpreted as 0 because here the node represents a system versus a process. The context diagram also includes key external entities and data flows. The next DFD level is level 0. This level decomposes or explodes the entire system into the main or primary processes within the system of the context diagram. This level takes the name level 0 because the reference numbers of the processes have whole numbers such as 1.0, 2.0, 3.0, and so on. Level 0 also introduces the data store component. When documenting level 0, we have to maintain the same external entities as the context diagram, as those serve as the sinks or sources for our inputs and outputs. The next level is the level 1 data flow diagram. The level 1 data flow diagram decomposes the main processes into subprocesses. The name level 1 comes from the fact that one decimal place is included in the reference numbers on the process nodes. Here, the whole number represents the process that is being exploded, while the decimal represents somewhat of a sequence of the subprocess it represents. For example, if process 1 is exploded into two subprocesses, they will be labeled as 1.1 and 1.2. A unique feature of the level 1 DFD and further levels is that they only require the processes and data flow inputs and outputs, which means that external entities are optional here. Also, at this level, we have to consider a concept called balance, which is maintaining the same key input and output labels from the primary process that we've exploded. As you can see here, process 1 has one input and one output. Therefore, the boundary of the subprocesses need to include those same inputs and outputs. The next level I'll discuss is level 2. One thing to note is that the data flow diagram levels can go as far as you need them to, but generally they don't go past level 3. The lowest level should include processes that make it possible to create a process specification document. The level of detail that needs to be illustrated is only that which is required based on the complexity of the data and requirements. Now let's talk more about level 2. The level 2 DFD decomposes the subprocesses into more detailed activities. Now, most literature on DFDs doesn't refer to these as activities, but I think considering concepts such as system decomposition or business system hierarchies can help determine when an additional level of detail of the DFD may be required. Like the previous levels, level 2 takes on its name because now we're considering two decimal points in the reference number. The whole number represents the process. The first decimal represents the subprocess, while the second decimal represents the sequence of the activity. Here, we have to maintain the same inputs and outputs as the subprocess that we exploded. Now let's look at some data flow diagrams, rules, and best practices. First, data must not flow between two entities. Data flow must be from an entity to a process or a process to an entity. There can also be multiple data flows between one entity and a process. Next, Data must not flow between two data stores. Data flow must be from a data store to a process or a process to a data store. Data flow can occur from one data store to several processes. Next, data must not flow from an external entity directly to a data store. Data flow from an entity must be transformed by a process before going to data store and vice versa. A process must have both input and output data flows. Every process must have input data flows to process the data and an output data flow for the processed data. Next, a data store must also have both input and output data flows. Every data store must have an input data flow to store the data and an output data flow for the retrieval of the data. The next rule is the number of processes in a DFD should not exceed 12. Some literature states 6 or 9 as the maximum, but the idea is to maintain simplicity and clarity. And last but not least, all the processes must be linked to at least one data store or another process in the system. Now let's take a look at some examples of data flow diagrams. In this example here, I'll be using Amazon as our case study. We'll start with a simplified context diagram of purchasing products on Amazon. The primary process node is Amazon's system to purchase products. The external entities here are customer, vendor, and customer financial institution. The flow of data is that the customer inputs user credentials and a product query. Amazon then sends an availability request to the vendor, and the vendor provides an inventory status. Then Amazon checks the availability of funds from the customer's financial institution. If the funds are available, the financial institution sends a payment to Amazon. Then Amazon will send an order confirmation back to the customer. Now let's explode the purchase product system into a level 0 diagram. Theoretically, a system for purchasing a product on Amazon would include 4 primary processes: complete login 1.0, search products 2.0, manage shopping cart 3.0, and complete checkout process 4.0. Now that we have our 4 processes, we need to incorporate the same external entities and overall inputs from the context diagram. We'll also add our data stores and data flows that occur between the processes. So the flow of data here will be as follows. The customer inputs user credentials to the login process. Then the login process validates the login. The user details data store here then sends the user profile to the user interface, where the customer will search for the products by entering a product query. From there, a product availability request is sent to the vendor. The vendor provides an inventory status, which allows the customer to select the products that are available. The product selection gets sent to the shopping cart, and the total amount for the finalized order details are sent to the checkout page. Here, the customer selects a payment method. The payment method details are retrieved. From there, the system will check the funds availability from the customer's financial institution. If the funds are available, the payment is sent back to Amazon, and upon payment, the checkout process is complete and the order confirmation is sent back to the customer. Now let's look at a level 1 diagram. To do this, we'll be exploding the complete checkout process from the level 0 diagram into 4 sub-processes, including enter shipping details 4.1, enter billing details 4.2, choose delivery 4.3, and select payment method sub-process 4.4. Since we've identified our 4 sub-processes, we can go ahead and omit the external entities if we want, because we're taking a more detailed view here. Now remember, a level 1 diagram must be balanced with the level 0 diagram, so we have to ensure that all of the input and output data flows from the complete checkout process are included here. Looking back at the level 0 diagram, we can see that the complete checkout process has 4 associated data flows, including order details, a payment input, a payment method output, as well as the order confirmation output. So these are included within the boundaries of these 4 sub-processes. So for these, the flow of data would be the order details are received, The customer enters the shipping details, which provides the shipping address to validate if the billing and shipping details are the same. The address information is then sent to the delivery section so the customer can choose the delivery method. Based on the method chosen, the total cost details are calculated and sent to the payment screen where the customer enters the payment method, which is retrieved from the payment details on file. From there, the system will check the availability of funds. If the funds are available, the payment is sent back to Amazon. Upon receipt of the payment, the checkout process is complete and an order confirmation is sent back to the customer. Now let's discuss the two types of data flow diagrams. These are logical data flow diagrams and physical data flow diagrams. Logical data flow diagrams illustrate what will happen to the data during the business processes and activities. Physical data flow diagrams illustrate how the data will move through the elements from a system perspective and how the physical structures will be implemented. To help delineate between logical and physical data flow diagrams, remember the following. Logical data flow diagrams focus on the business perspective. They illustrate what will happen. They focus on business operation goals, and a business analyst or a business system analyst usually creates this type of diagram. For the physical data flow diagram, the focus is on the system perspective. It illustrates how the data flow will happen. It facilitates the system implementation, and usually a developer or database analyst will create this type of diagram. When creating logical versus physical DFDs, you just need to adjust the perspective of what you're representing with the elements. For example, the main process node might be to complete a specific process, while in the physical DFD, that process node would represent the physical system in which the process occurs. To compare logical and physical DFDs, let's look at a simple context diagram from our Amazon example. Here, we have our customer providing user credentials in order to purchase a product, which is a process, and then a payment method is sent to a data store. Adding implementation references is done for processes, data flows, and data stores, but not external entities. Data flows may be forms, input screens, fields, records, or output reports. Data stores are generally tables in a database or files. Processes may be systems, applications, or programming languages. Also, it's a common practice to create a human-machine boundary. So here, we create the human-machine boundary between the customer and the interface with this dashed line here. Then we see that in the physical DFD, the user credentials are passed from a login form, and the purchase product process is done through an ordering system or website. Then the payment method is entered through a payment selection form and passed to a SQL payment table to be retrieved. Well, there you have it, folks. That's what you need to know to properly create the various levels of data flow diagrams. If you learned something new, tell me about it because I'd love to hear your feedback. Also, be sure to check out all of the business analysis and BA certification training resources we have for you on our website at thebadoc.com. Thank you so much for watching. I hope you have a productive and prosperous day. Until next time, bye now.